Hi guys, in this video it's almost at the end of what we're gonna do on this basic character. At the very end we're gonna get some basic puppet functionality. This rig is still not implementing anything such as bendy limbs, squash and stretch or anything like that, or any advanced facial with blend shapes. I'm taking the chance for this video just to add a couple of things and do a bit of cleanup and reviewing a bit of modules, what I've done so far. So last time we left the rig. Let me just slow this down. Oh, it's already. Last time we left this out with this functionality where the eye was following this control, both eyes individually. And that's great. And then on top of that, you would have an FK control that allows you to offset. And this is to achieve some kind of convergence, and then being able to animate from there. Okay, because the eyes do not ever look completely parallel when they stare at something, especially if it's close. So if it's close to the face, I mean. So it's working, but it's really not convenient when it comes to animating something that moves and flies around, because you have to deal with two different set of keyframes and things can get a little bit complicated in the graph editor. So it's common sense to add a group above or a control above of these two controls, so the animator can move it around as a unique entity, and you can constrain this object to something. So when you rotate the head, the eyes are always staring at it, or you can have this object constrained to a flying around, and a combination of the head and the character movement and this object moving around constrained to the bug flying. It gives you the proper behavior for the eye stare. So by default, you can see that how this is done. We're going to see it, and it's nothing else than a very similar implementation when it comes to the spaces. But so by default, when I move the head, you can see that this object does not move with the head. So by default, you get this behavior where the eyes are staring at it. If we navigate through the settings, there is an eyeAim space, and if I turn this on now, what happens is that now the object does follow the last item in chain that is attached to the skull. In this case, this circle here. So this works with the circle as well. So how is this done? Let's have a look at the hierarchy first. So at the very end of the chain of the head, we had the FK control, which happens to be this circle here. Children of that, there is now a space, and it's called aim local space. And children of that, there is this control. And children of this control, there are the two IIK controls that we left previously. They were left behind. So now they finally have a parent, a place to be. These two controls are children of this big yellow square, and the yellow square, it's on its own, it lives in a space. So in this mode, basically this is nothing else than an FK chain, because I have an head FK control which moves all the children. So it moves the local space, which moves the aim control, which moves the IK. So it's nothing, this is just a very simple hierarchy. And this is in this behavior, everything it's in a chain, meaning that 1, 2, 3, 4, they're going to move in a chain. And if I go above of the head FK control and I move the head IK, everything still works. When I change the setting back to false, this kind of chain behavior it's interrupted. And the reason is that this local space, it's where I'm performing the space change. This local space now is not driven by simply being parent of the head FK control, but rather it's driven by its sibling world space, aim world space. So you can imagine that this local space is children of the head by default, so it will follow. But if its transform now is driven by something that never moves or rotates, then that's why this now it's locked in space. Okay, the world space, the aim world space is children again of all the world spaces group, and this world spaces group is children of this object here, which again I keep repeating this. This represents our world space, and of course the parent of it. So how is this done? So again, we are working with local space and world space. Let's have a look at the module. And the first thing you notice is that, again, in the I kept separated the eye module from the eyeAim module because these two things can be used in many different ways, meaning that the eye, I can have more than one eye. You can use this module eye for a spider and everything will still work. But in case of a bipedal or maybe a quadruped, something that always have two eyes, then you can use the module eyeAim to group these two things together, so you automatically get this behavior. So that's why the module eye is still a separate entity. It's so you can reuse in something that is not canonical or something that has more than two eyes. So what you would do is simply duplicate this module eye, fill the fields here, and then you know, keep going. It would work. So let's have a look at the module eyeAim. Module eyeAim takes as an input the two bones of the eyes and these two bones, and this module is exactly the same as all the other modules. I'm running, if I check the rig graph, I have a setup mode for the setup event, and then when I'm not in setup mode but I'm in forward solve, the setup event is disabled. So if I look into it, the first thing I check, am I in setup mode? Yes. What I'm doing is basically I interpolating between the position of this bone, left eye bone and right eye bone, and the alpha for the interpolator is that the blend value, it's 0.5. So at this point, what I'm doing is that I'm setting the local space and the world space to be exactly in the center between these two eyes. Because remember, what we're trying to do in the setup event is place this control position procedurally. Same way we were doing with that, I want to be able to do it with that. So I'm interpolating. I have an alpha here. I'm setting the values from, you know, from here to here. And sorry, I'm setting the values of the local space and the world space, and this one and this one. These two, this one happens to be the local space and this one happens to be the world space. And I'm setting the values for them to be exactly in the center by interpolating the translation. And then on top of that, I'm adding a vector, which is the offset, control offset. So if you see control offset here, it's Y30, which means it's starting from the center in between the two eye joints. I'm moving it 30 units. And if you notice, it is exactly the same technique that I'm using and the same value that I'm using for the eye module. So these two values can potentially become a variable or you know, and always be the same. I want to keep them independent because I work in scenarios where the eyeAim had to be offset differently from the eyeK. But in this case, in this very simple case, this is it can be identical. So you can see I'm computing the position of this circle pretty much in the same way as I'm computing the position of this square. The only difference that this circle, if you remember from the eye module video, this circle is only using the bone position and then offsetting, while this one is using both a bone position of both eyes being in the center and then offsetting. What you get is it's basically both of them being perfectly aligned, and that's because math. So how, let's keep going with the module. So mine setup mode, yes, then place the objects, the two spaces procedurally. And I'm not in setup mode. No, I'm not. So am I in? I'm in forward solve. Forward solved. the first thing I do, I'm checking if I need to follow the head. And now you can notice that if it's true, I'm doing nothing. And the reason why I implemented this way is to show you a different way to implementing spaces. Instead of swapping, if you remember, between a module leg and a module arm and a module spine, if it was true, we were connecting translation only, or transform. Sorry, we were connecting both transform. And if this was false, it was just translation and rotation from the world space. In this case, because this one, it's either locked or non-locked, it's not like it needs to follow a rotation and translation. Then the setup is way simpler, because if I want the if I want the follow head to be true, then you simply need to follow its parent, which is the head FK. You don't have to do anything. Basically, you can do this in a kind of FK chain. If it's false, which is how it's set now, if it's false, basically what I'm doing is I'm getting the world space, getting the transform of it, and setting the transform of the local space. And their initial position is actually identical, because they get snapped to the same exact position, which happens to be, here. Sorry, here. So these two objects are at the very beginning on the same position. So when this is on, when follow head is off, then it's the world space that is completely driving the local space in transform mode. So this is it's the same concept but applied differently, because in the case of the FK arm, the FK arm always had to follow the spine. It never had to be locked in space. So we had to implement a rule for transforming, for translation, and a rule for rotation. In this case, it's either it's following the transform, or it's following the transform of the world space. So that's why the setup is a bit simpler. And this is the behavior that you get. So this is it for the eye module. Now, just to go through a little bit more cleanup of what I've done so far. Let me close and let's have a look. So in my blueprint, what I've done is that first I adjusted a little bit the comments, and then what I've done is for each function I've done this here and there, but now I've done it on them all. In each function, what I've done is I've used Boolean types to create separator, bones, control, settings. You see this thing here? I don't have a separator type, or at least I think I don't have it. I wish I did. But anyway, this works. So this is just for a visual feedback for the user. So you know that this below here, this category is related to bones, this category is related to controls, and this category is related to settings. And I've done this on pretty much every module. This is something that I'm doing for myself, because in 2 months from now I will completely forget what I've done. So you can see you have bones, controls, and settings, etc., etc. Another thing I've done is that, and this is, I strongly suggest you do what I'm about to say, and the reason is it makes things so much simpler and so much easier for the user to use one of the nodes that you guys implement. Always remember to set default values for the node, and the reason is it gives you out of the box. If I drag and drop the module I, and so out of the box, I forgot to untick autocompile. So I've noticed this, that sometimes when I drag a new function with autocompile on, it takes a little bit longer to do things. Anyway, if you fill in here pre-made values, then even if the user is using a different skeleton or a different control scheme, at least this represents some kind of guide of what is what. So you could say, here, what the developer means is that I need to put the FK control in it, or I need to create an FK control. So always, and the same goes for all the offsets and settings you do. It's always nice to put a default value, not just because when you drag and drop it, the node is pretty much ready, assuming that you're using the same exact skeleton and control scheme I'm using here, but also in the case that you're not, it provides the user with a guide. So this is a win-win. It's good for you because the node is ready, or it's already filled, and it's good for the user when it's trying to understand the system that you're building. Okay, so this is now taking a little bit longer than expected. Hi guys, sorry, I had to interrupt the video and pause it because it took about 2 minutes to get me back the UI, and I've noticed that behavior sometimes. It happens when autocompile is on. Yeah, so sorry about that. So let's keep going. So we were talking about this control here, and we saw how it was implemented. Another cleanup, or visual cue I've added, is this line here. This line, it's been drawn between the pole vector and the bone, and it appears only when IK is involved in certain structures or in certain modules. And the reason is, it's not just, you probably have seen this line everywhere, and the reason is, if you're animating a character, let's say a bipedal, and it's on its own, then there is really no need of this line. This line, it's not just because it's fancy, it's more about, imagine that you have a fighting scene where you have 10 of these characters, you have 10 bipedal characters, and they all have a similar bipedal rig, because you're going to share control rigs. If you're working in the viewport and you need to understand, you will probably end up having so many of these controls floating around that yes, you can select the control, and by looking at the naming or at the hierarchy, you can easily understand where this control is coming from. But as a visual feedback, it's always nice for being able to move this control around and have the line pointing directly to the knee of the bone, so you understand basically the vector, and visually, instantly, you know where it's coming from and what is moving. So that's why this line exists. One thing worth mentioning is that, how did I implement this line? Well, Unreal makes it really simple. In a standard DCC application, what you would have, you would have a 2 points linear NURBS curve with 2 control points, control vertices. Each control vertices will be driven by the wall matrix of a locator. The locator will be parented underneath this control, and the other locator will be parented underneath the bone. And because you're deforming the curve, and the curve is purely linear, it's made by 2 points, you get the impression that the curve is always pointing to that. In Unreal, you don't have to do any of that. You simply can call the function draw curve between 2 transform. And the cool thing is that I didn't have to do this, and this is another cool thing about having everything split in modules. So I didn't have to do this on the module of the leg, but and one for the arm and one for whatever IK. I only had to implement it in the solver IK, and here it is. At the very end of the solver IK, I said, give me the bone, give me the control transform, this one, and give me the bone of the knee, and draw line. And then you have options to deal with the thickness and the color. I set the color to be black and the thickness to be as thin as I could. Now, because I implemented in the solver IK, and because the solver IK has been used by the solver IKFK, and because the solver IKFK is being used both by leg and arms, what I got is automatically I got in the arm IKFK. If I switch this, you can see that this line is implemented. So I only had to literally put these 3 nodes, and suddenly everywhere I had an IK solver or a pole vector, this function arrived. So this UI, this line got drawn. So this is another cool thing. By simply adding a functionality in a solver, everywhere that solver is being used, you get a functionality for free. So this is kind of the end of this first part. Again, this rig is nothing. It's very similar in the end to what you could get from the examples that you find from the Epic store. The mannequin. It's what I consider being a basic bipedal puppet. This is a puppet. It doesn't include any volume preservation. It doesn't include any squash and stretch, and we said that. So on top of that, when at the very beginning of the series, we discussed that there are three major events in control rig. There is setup event and forward solve. The third one is the backward solve, and as you can see, I haven't touched about it. I haven't talked about it yet. The reason is what I wanted to achieve first is a basic understanding on how to connect things together. Rather than giving a full recipe, I wanted to discuss rigging theory really, and one way to implement things, which is, it can change. It's probably going to change in the future. Probably we will all find a better way to do what I've done here. So getting acquainted with control rig really was the goal. So what's gonna happen is that in each module, then we will also have to implement the backward solving. We're gonna talk specifically about the backward solve in its own videos, and we're gonna start implementing it. It's very powerful, but I consider this, if you want, kind of a, this is a milestone. With this video, you will end up having a puppet that can be animated in forward solve, as this was a standard application, a standard rig. This could be Maya or Blender. By moving and implementing, so this is this is a milestone. Moving forward, once we start implementing backward solving, this is where you can do a lot of stuff, such as remapping motion capture onto a control rig almost instantaneously. So convert motion capture data into control rig animation space, which is really cool. And on top of that, after that, because now the basic biped is implemented, there's all sorts of things that we need to start talking about, like volume preservation modules, or helpers, or even blend shapes, morph targets, how to add those things, and last but not least, there is all sort of dynamic solvers that comes with Unreal Engine that I briefly touched, but I haven't spoken about yet because I'm still not comfortable. I still didn't understand the math behind it. So those are coming. You can see them around. All the video tutorials about control rig are showing them. They are pretty awesome. But I still don't feel comfortable talking about it. But I will. Okay. So yeah, that's it. Bye.